Welcome to another episode of Tutorials with Ike. Today we're going to be looking at matrices under quantitative methods. Now when it comes to matrices, there's a particular question that usually comes in exams, which is a 3 by 3 matrix. And when it comes to matrices as well, all the questions are also practical, you get it? They are application based. So you're going to take a practical question, especially the one that usually comes, so that we'll have a fair idea of matrices, you get it? So at any time a question comes under matrices, you know how to go about it. So for this particular question, please take it very serious because I've been reviewing the past questions and I've been seeing that every time this is how they set the questions. So we are going to take a question under the 3 by 3 matrix, which is also something I'm predicting to come this year. So please try and take it very seriously. They are going to break it down. So even if you have no idea in matrices, we are going to break it down so that you understand it very well. You get it. All right, so let's take the question. So the question says, John received an inheritance of $12,000 that he divided into 3 parts and invested in 3 ways. In a money market fund paying 3% annual interest, in municipal bonds paying 4% annual interest, and in mutual funds paying 7% annual interest. John invested 4,000 more in mutual funds than in municipal bonds. He earned $670 in interest the first year. A. Write down the 3 linear equations. B. Represents the system of equations in a matrix form mx is equal to n. C. Find the determinant of the matrix M. D. Hence, calculate the amount John invested in each type of fund by using matrix algebra. All right. So yes, like I said, this question usually comes almost every year. You get it. So we are going to break it down. So even if you have no idea in matrices, you are going to understand it. You get it. All right. Now, let's first understand the question. So the question says that John received an inheritance of $12,000. You get it? So maybe his father died or whatever, and now his inheritance is $12,000, which means that's what he has. So he has $12,000 on him. But then it goes on to say that he didn't want to waste the money. You get it? He decided to invest it in different places. So it says John received an inheritance of $12,000 that he divided into 3 parts. So this $12,000 is what he divided into 3 parts. So he first invested it in a money market fund, paying 3% annual interest. You get it? So he invested part in a money market fund, which was paying 3% annual interest. They invested another into municipal bonds, paying 4% annual interest. Then the last part, he invested it into mutual funds, paying 7% annual interest. So that's how he decided to use the money. He didn't decide to, waste it or anything. He decided to invest it into 3 different places, paying different interest. You get it? So in case one fails, at least another will not fail. You get it? Now let's continue. So it also goes on to say that John invested $4,000 more in mutual funds than in municipal bonds. You get it? Then the latter part of the question says that he earned $670 in interest the first year. So what that means is that when you add the interest for all of them, you see he divided it into 3 parts. So the first one was municipal bonds. No, the first one was money market fund. The second one was municipal bonds, and the third one was mutual funds. So the interest you get for all of them, when you add all, he got $670. You get it? So the interest for all the 3 is $670. So he earned $670 in the first year. So now that we've understood this, we can answer the questions. So how do we answer a question like this? So the A says write down the 3 linear equations. All right. So in writing the 3 linear equations, know that he has received $12,000 and he has divided it into 3. You get it? So the first one is money market fund. So let's write it on the board. So the first investment, he invested it into a money market fund. Right? Money market fund. Then the second one, he invested it into municipal bonds. So the second one, municipal bonds. Then the last one, he invested it into mutual funds. So these are the 3 investments that he decided to invest his money in. Money market fund, municipal bonds, and lastly, mutual funds. You get it? So if we want to get the linear equations for the information given, we have to represent this by variables. So you can decide to represent this by A, B, C, B, C, D, or whatever. But usually we use X, Y, Z to make it very simple. So we are going to represent money market fund by X. So into brackets X. Then the second one, which is the municipal bonds, we are going to represent it by Y. Then the last one, which is the mutual funds, we're going to represent it by Z. This one, the question didn't specify that you should represent any of them by X, Y, so you can decide to use any letters. You get it? But we want to just make it easier. That's why I used X, Y, and Z, because I'm sure you guys are used to it. You get it? And the reason why we represent it by letters is that we want to make it easier to solve. I mean, when you represent all this long thing by X, it will be easier to solve as compared to you representing it by the normal money market fund and all that. All right. So now that we've represented money market fund by X, municipal bonds by Y, and mutual fund by Z, we can write down the three linear equations. Now let's go back to the question. The question says that John received an inheritance of $12,000 and he divided it into three parts. So these are the three parts that he divided it into: the money market fund, municipal bonds, and mutual funds. But he received $12,000. So the $12,000 is what has been divided to get this: the money market fund, municipal bonds, and mutual funds. So it means all this three, when you add all of them, you should be getting $12,000. You get it? So we can say that money market fund plus how much he invested into the municipal bonds plus how much he invested to the mutual funds will be equal to our 12,000, because that's the money he got, the $12,000. This is what he invested them into. So he invested part into this, this, and this. And when you add, you are getting $12,000. I hope you get it. So earlier on, we said you are going to represent money market fund by X. So anywhere you see X is the same as money market fund. So X plus our municipal bonds, which is Y, plus the mutual funds, which is Z. So these are the three things he decided to invest in, the three investments. So this should be equal to our total investments, which is what is given in the question. That's $12,000. So this will be equal to 12,000. You get it? And like someone has given you $12,000, you decide to invest it into maybe MTN, Airtel, Tigo, and Telecel. When you add all the investments, it should be equal to how much the person gave you, which is the 12,000. It can't exceed it. You get it? So when you add all the investments, X, Y, Z, which is the money market fund, municipal bonds, and mutual funds, you should be getting the 12,000. Now this becomes our first equation, or our equation 1. What else did the question give us? So let's read the question again. So it says that John received an inheritance of $12,000 that he divided into three parts and invested in three ways in a money market fund, paying 3% annual interest. You get it? So for the money market fund, you are going to get an interest of 3%. You get it? So I can just put it beside it. So or 3%. This is the interest you are making. That's for the money market fund. Then the municipal bonds. So in municipal bonds, paying 4% annual interest. So for the municipal bonds, which is our Y, we are getting 4% annual interest. Do you get it? Then lastly, mutual funds. We are getting 7% annual interest. All this is stated in the question. But when you go on to read the question, it says that John invested 4,000 more in mutual funds than in municipal bonds. We'll come back to that one. So it says that he earned $670 in interest the first year. Please pay attention. So what that means is that all this, the total interest he got was $670. He said that the question says that he earned $670 in interest the first year. They didn't specify. So it means that when you add all the interest you are getting for each investment, you should be getting $670. However, for money market fund, they've already given you the interest. You get it, which is 3%. For municipal bonds as well, they've already given you the interest, which is 4%. And for mutual funds as well, they've already given you the interest, which is 7%. So if they've given you the interest for each of them and they've given you the total interest, you can equate the individual interest to the total interest. You get it? So let's start with the money market fund. We are getting a 3% interest. So what do we do? 3 over 100. So 3, anytime you see percentages over 100. So 3 over 100 is going to give you 0.03. So to get our equation, or our second equation, we are getting the money market fund, which is 0.03. That one is for the money market fund. So 0.03x, because anywhere we see money market fund, we put x there. Then plus the municipal bonds, which is 4%. So 4 over 100. Anytime they give you percentage in this question, you divide this by 100. So 4%, which is 4 over 100, will give you 0.04. 0.04. And that's for municipal bonds. So why? Because we decided to represent the municipal bonds by y. Then plus the mutual funds, which is 7%. So 7% is 7 over 100, which will give you 0.07. So 0.07. And that's Z. So because you decided to represent mutual funds by Z. So 0.07Z. Then this is equal to, remember what we just wrote is the interest for all of them. 3% is 0.03, 4% is 0.04, and 7% is 0.07. These are the individual interests. So this interest, the individual interest, should be equal to the total interest in the question, which is 670. You get it? So this should be equal to 670. I hope no one is confused. This is the interest for money market fund. This is the interest for municipal bonds, and this is the interest for mutual funds, which is here. So when you add all the interest, it should give you the total interest for that particular year, which is 670. You get it? All right. So now that we've got the second equation, we can move on to the last equation. The question says we should write down the three linear equations. So we've got two equations. Let's start with the last one. What other information did the question give us? So I take the question again. John received an inheritance of $12,000 that he divided into three parts and invested in three ways: in a money market fund, paying 3% annual interest; in municipal bonds, paying 4% annual interest; and in mutual funds, paying 7% annual interest. John invested $4,000 more in mutual funds than in municipal bonds. All right. So you've not written anything on that. So I take that part again. John invested $4,000 more in mutual funds than in municipal bonds. So it's just in that what he invested in mutual funds is equal to 4,000 more than what is in the municipal bonds. You get it? So if John invested 4,000 more in mutual funds, so our mutual funds is Z. So it's telling us that the Z, which is the mutual funds, is equal to John invested 4,000 more in mutual funds than in municipal bonds. So our mutual funds is equal to 4,000 more than the municipal bonds. Our municipal bonds is Y, so 4,000 plus Y. So please don't make a mistake to bring the Y at this side and the Z at this side. They say that, the question said that John invested 4,000 more in mutual funds. You get it? And this is mutual funds. So mutual funds is equal to 4,000 more than that of the municipal bonds. You get it? So 4,000 plus the municipal bonds. Our municipal bonds is Y. So anywhere we see municipal bonds, we bring Y there. So this becomes our third equation. So Z is equal to 4,000 plus Y. You get it? We can bring the variables to this side, just like what we have for the first and second. So this will be equal to Z minus Y. We'll let the Y cross the equal sign to become negative. Z minus Y is equal to 4,000. You get it? So we can make this our third equation. You get it? So we've changed this to this. So now that we've got the three equations, you are done with the A. So you are going to get marks for this one, maybe 2 marks each or something. Yes, so A, write down the three linear equations. You are done with the three linear equations. So our first linear equation is the X plus Y plus Z is equal to 12,000. Then the second one, which is 0.03x plus 0.04y plus 0.07z is equal to 670. Then the last one, which is the Z minus Y is equal to 4,000, or Z is equal to 4,000 plus Y. When you do a change of subject, that becomes our third equation. So you're done with the A. All right, so let's move on to the B. So the B says that represents the system of equations in a matrix form mx is equal to n. All right, so M is the matrix. You get it? The 3 by 3 matrix you are going to get. Then X is the variables, the X, Y, Z. Then N is whatever is after the equal sign. So the number after the equal sign. So don't worry, I'm going to break it down so that you understand what I'm saying. So now mx is equal to n. So let's start with our m. So our m is the matrix And since you are getting three equations, anytime you get three equations, just know you are getting a 3 by 3 matrix. In fact, any question that is going to come under matrices is most likely going to be 3 by 3. So just put it to your mind, once you are getting three equations, or even x, y, z, just know you are getting a 3 by 3 matrix. So when you write the m is equal to, then you open the brackets. Then what you are going to do is you are going to take the coefficients of each of them. So the x, y, z for each of them. You get it? So let's start with the first equation. So the first equation, we have x plus y plus z is equal to 12,000. So x, the coefficient for x is what? 1. So you write it here, 1. Then y, the coefficient for y is also 1. Then we also write it here. You get it? Then z, the coefficient of z is also 1. Then you write it here. If you had 2x, the coefficient would have been 2 if you have 3x. But once you have only a variable, the coefficient is always 1. Do you get it? Now I move on to the second equation. So for the second equation, so for now, I'm just going to do what is before the equal sign. This one will come later on. So for the second equation, 0.03x plus 0.04y plus 0.07z. So you take the coefficient of the x, y, and z. You get it? So for x, the coefficient of x is what? 0.03. So you write it here, 0.03. Then for y, the coefficient of y is what? 0.04. So you write it here, 0.04. Then lastly, for z, the coefficient of z is 0.07. So 0.07. You get it? Then we go to the last equation, which is 7 is equal to 4,000 plus y. When you did a change of subject, we got z minus y is equal to 4,000. But here we didn't have x. You get it? So if you get any equation and there's no x or there's no variable, then obviously it becomes 0. So here becomes 0. Here is supposed to be for the x column. You get it? But we don't have x. Z minus y is equal to 4,000. There's no x. So x becomes 0. Now here is supposed to be for y. Remember here was x, 0.03x, 0.04y, and 0.07. You get it, 7z. So here is supposed to be for our y. It's supposed to be x, y, z. So our y is negative y. So negative y means the coefficient is negative 1. If it was z plus y, the coefficient would have been 1. But because of the negative, we bring negative 1. So that becomes our coefficient for y, negative 1. Then for z, our coefficient is 1 because we have z minus y. It's not negative z, so we don't bring negative. So our coefficient for z is 1. So now we are done with the matrix. You get it? So this is our m. Now the question says you should write the equations in a matrix form mx is equal to n. So we write our x. What is our x? So our x is just simply the variables. So the x, y, z, that's our x. So x, y, z. So this would also depend on the variables you decide to use. You get it? You might decide to use a, b, c. So your x will become a, b, c. The first letter will come first. The second letter will come second. And the third letter will be the last one. You get it? So now the x, y, z is our x. So we've got our mx. So this is our m, which is a 3 by 3 matrix. 1, 1, 1, 0.03. 0.04, 0.07, then 0, negative 1, 1. This is our m. And the x, y, z is our x. But the question says we want it in the form mx is equal to n. You get it? So mx is equal to n. Now what is n? N is just the constant after the equal to sign, or the numbers after the equal to sign for each of them. So for x plus y plus z, the number after the equal to sign is what? 12,000. So into brackets 12,000. Then for the second equation, which is 0.03x plus 0.04y plus 0.07z, the number after the equal to sign is 670. You get it? So here will be 670. Then for the last one, which is 7 minus y is equal to 4,000, the number after the equal to sign is 4,000. So the n is basically the part that is not attached to a variable, only the numbers after the equal to sign. That's why most of the time it's better to group it. So you bring the variables to the left and the ones without the variables to the right. You get it? So that you don't make a mistake when you are grouping them. So now we are done with the B, which says you should represent the system of equations in the matrix form mx is equal to n. So this is our m, this is our x, and this is our n. You get it? So mx is something like mx is equal to n. That's all. So now we are done with the B. Now let's go to the C. The C says you should find the determinant of the matrix M. And a lot of students have a problem when it comes to this side. So we'll take it step by step. So now that we've got this, we can just clean this part. All right. So the C, find the determinant of the matrix M. So anytime you're asked to find the determinant of a matrix, a 3 by 3 matrix like this, so that this is the matrix M. So you are saying we should find the determinant for this one. You get it? So let's first write it at the top. So we have, let me bring it down a little. So you have our C, so into brackets 1, then 1, 1. Then another one, we have 0.03, 0.03, 0.04, and 0.07. And here we have 0, -1, 1. Do you get it? All right, so this is just the same thing that is here. I've not done anything. I just repeated what is here at the top. You get it? So now that we've got our matrix M, the question says that you should find the determinant of this matrix. So how do we find the determinant? Now, the first thing you have to know is that we are going to use the ones at the top, the 1, 1, 1. If it's 2, 2, 2, use the same. If it's 2, 3, 5, it can be different or it can be the same. This time is the same, so 1, 1, 1. We're going to use it to be multiplying these ones. And you have to keep in your mind that this one, the first one, is always positive. So plus. Then the second one is always negative. Then the last one is always positive. So it's positive, negative, positive. Positive, negative, positive. You get it? So now, this is how we are going to do it. The one at the top, this one here, the one at the plus on top, this one is going to multiply. So let me just do it. So when you take this one, this side and this side cancels. You get it? The row and the column for the one. So this side and this side cancels. So it's something like here and here. Then it's going to be left with this side 0.04, 0.07, -1 and 1. You get it? So it's going to be 1 times 0.04 times 1, then minus 0.07 times -1. I'm going to repeat it again. When you want to find the determinant for a matrix like this, you first multiply this one. So just put in your mind, the first thing I'm going to do is that here is positive, negative, and positive. You get it? Then you take, since this is positive, it's going to be positive 1, then times. So when you take this one, this side is going to cancel the row and column for this side. So it's something like this and this. You get it? So now all this has cancelled. You get it? So it's now it's left with this 0.04, 0.07, -1 and 1. They are not on the same row and column as this one. You get it? So now it's going to be 1 times whatever is left. You get it? So it's going to be our 1, this one here. And since it's positive 1. So into brackets, so you bring a big bracket first. Then into brackets 0.04. Then times 1. So this times 1, then close the brackets, minus into brackets 0.07. 0.07 times this -1. Times this -1. I hope you get it. So always you take the first one, which is 1, then you multiply it by this times this minus this times this. Do you get it? Now, we are done with the first one, which is our positive one. So let me clean the line here so that you don't get confused. All right. So we are done with this positive 1. So this 1 multiplied this, and this. Now we go to the next one, which is the negative 1. I said this is positive, negative, positive. So for the next one, it's going to be negative 1. So let me just bring it down. So minus 1. Then you open a big bracket into brackets. So we are getting, let me just clean. I don't know if I should clean this part. Okay, let me leave it. So minus 1. So minus this 1. Then this one, so you take the numbers that are on the same row and the column. So they are not parts. So this negative 1, you cancel all these parts. Then you cancel this part as well. So the numbers you cancelled are not parts. This, and this. The ones cancelled are not parts. Then you take the ones that you didn't cancel. You get it. So it's going to be the same process. So this negative 1 times what is left. So 0.03 times the 1. 0.03 times the 1 minus into brackets. So 0.03 times 1 minus into brackets 0.07. 0.07 minus 0.07 times the 0 times 0. Do you get it? Then you take it for the last one, which is the positive 1. So the ones at the top, they are the ones going to be multiplying what is at the down. You get it? So now let me clean the line so that all right. So now let's see this positive 1. So we can do that one below this one. You let me clean this part of the board so that all right. So we have this minus this, then plus, then we open a big bracket. So plus 1. It's a plus 1 into bracket. It's plus 1 because here it's positive. So it's positive, negative, positive. So plus 1 into bracket. So you open a big bracket for the into bracket. So for this side to plus 1, you take the numbers here and here. Then so those numbers are not parts. To be left is 0.03, 0.04, 0, and negative 1. You get it? So for that one, it's going to be 0.03 times negative 1. You get it? 0.03 times negative 1. Then minus into brackets 0.04 times 0. 0.04 times 0. So this times this minus this times this. Always, that's what you do. You get it. So after you do for this one, to this times this minus this times this. I hope you get it. So now that we are done, we just punch all this on the calculator. So you have 1 into brackets 0.04 times 1. And close the brackets minus into brackets 0.07 times negative 1. Then minus, get a minus 1 into bracket 0.03 times 1. Then close the bracket minus into bracket 0.07 times 0. Then close the bracket. Then plus 1 into bracket 0.03 times negative 1. Then minus 0.04 times 0. I hope you get it. So let's start step by step. So let's start with this part. So 1 into brackets, 1 times whatever is here is the same as 1. So you can just do what is here because it's just multiplied by 1. At the end of the day, you get the same value. So 0. Let's punch this part on the calculator. So into brackets 0.04 times 1. 0.04 times 1 minus into brackets 0.07. 0.07 times negative 1 times negative 1. So this will give you 0.11. So 0.11. That's for this part, the top. Then minus 1. So you have minus 1 into brackets. So negative 1 times whatever is here. So minus 1 into brackets So into bracket 0.03 times 1. So 0.03 times 1 minus into brackets 0.07 times 0. So you are getting 0.03. So minus 1 into bracket 0.03. You get it. Then plus 1 into brackets. So it's going to be the same. Whatever is here, plus 1 times this will be the same as plus. You get it. So plus into brackets. You can just do it plus 1. So plus 1 into brackets 0.03. So into brackets 0.03 times negative 1 minus into bracket 0.04 times 0. You are getting negative 0.03. So it's not going to be positive again. So negative 0.03. You get it. So you are getting 0.11, which is for this part, minus 1 into bracket 0.03, then minus all this part 0.03. So you punch it on the calculator, then let's see our final answer. So 0.11 minus 1 into bracket 0.03 minus 0.03. So you're getting 0.05. This is equal to 0.05. You get it. So 0.05 is our determinant. Depending on how you do your calculations, yours might be negative. If, let's say, this part comes here or something, yours might be negative. You get it. But the final answer for the D, when you find for X, Y, and Z, should be the same. So our determinant for the matrix M is going to be 0.05, which is our answer for C. You get it. You might get negative depending on how you arranged your values. So our C is 0.05. Now let's move on to the D. The D says that hence calculate the amount John invested in each type of fund by using matrix algebra. All right. So anytime you are asked to calculate the amounts for X, Y, Z, they are just saying you should find X, find Y, and find Z. Get it? So find the variables. So anytime you're asked to find the X, Y, and Z, or the variables, or the amount invested in it, you use what we call the Cramer's rule. Cramer's rule. So I'm going to explain it. Now, for the Cramer's rule, let me clean the board so that I explain it better. So just don't forget the values you use because we're about to use it for the Cramer's rule. So our determinant is 0.05. So for Cramer's rule, if you want to find the value of X, let's say you should find the amount you invested, and we represented it by X, Y, and Z, remember from the beginning. So now we are going to find X, find Y, and find Z. So if you want to find X, according to the Cramer's rule, X is equal to the matrix of X, or mx over, which is the determinant of mx over the determinant of m. Then y is equal to the determinant of the matrix y over the determinant of m. Then finally, for z, z is also equal to the determinant of the matrix z over the determinant of m. So don't worry, we are going to take it step by step. But just put in your mind, for the Cramer's rule, this is how you go about it. Now, let's start with x. So now I'm going to find the value of x. So how do we find the matrix of x? How do you find the determinant of mx? We've already found the determinant of m, which is what we just solved for in C. Find the determinant of matrix m. So anytime you see these two lines attached to it, it means the determinant of it. So how do you find the determinant of m? For the determinant of m, we already found it in C. You get it? That's what we got, 0.05. So for the determinant of m, we've already got it. So now we only need to get the determinant of mx, the determinant of my, and the determinant of mz. Then we divide. And how do we find for it? I hope you've not forgotten the equations we got earlier on, our equation 1, 2, and 3. Let me just write it down so that you don't forget. So the first equation, we got x plus y plus z is equal. Let me bring it down so that... So our determinant was 0.05. So let me write it here. Okay, so for the first equation, which is the a, I'm sure if you guys were solving it, you still have it in your book, so it will be easier for you. So the a, which was our first equation, we got x plus y plus z is equal to 12,000, right? Because we said the total investment is 12,000, you get it. So this was our first equation. Then our second equation, we said 0.03x plus 0.04y plus 0.07z is equal to 670. And we said this because the interest, when you add the interest for all, we're getting 670. I hope you've not forgotten that. Now for the last one, we said that z minus y is equal to 4,000. So these were the three equations we got. This, I hope you guys have not forgotten. So these were the three equations we got. X plus y plus z is equal to 12,000. 0.03x plus 0.04y plus 0.07z is equal to 670. Then z minus y is equal to 4,000. Yeah, so these were the three equations we got. Now to find the matrix of x is going to be, so our matrix of x. So since you're finding the matrix of x, wherever the x values are supposed to be, the matrix form, if you wanted to find the matrix for this, it would have been 1, because here the coefficient of x is 1, then the coefficient of x, which is the second one, is 0.03, then the last one, it was 0. I'm sure you guys know the matrix form. But for this one, when you are finding the matrix of x, you're going to replace all the x values by what is after the equals to sign. You get it? So 12,000, 670, and 4,000. That is what is going to be our x values. You get it? So instead of 1 here, we are going to get 12,000. Then the second one, we are going to get 670. Then the last one, we are going to get 4,000. Ideally, it's supposed to be 1, 0.03, and 0, which is what we got earlier on. So please go back and check our calculation. So it's supposed to be 1, 0.03, and 0. You get it? But when you are finding for the matrix of x, you replace the x values by what is after the equal to sign. So the first one by 12,000, the second one by 670, and the last one by 4,000. Similarly, if you are finding for the matrix of y, which we'll do very soon, you're going to replace all the y values by 12,000, 670, and 4,000. Then lastly, if you are finding for the matrix of z, which is our mz, or the determinant, you're going to replace all the z values by 12,000, 670, and 4,000. But the rest are going to be the same. So let's solve for this one and we'll solve for the other two, then you understand what I'm saying. So now our x values are going to change to whatever is after the equal to sign. But our y values and our z values are going to remain the same. So for our first equation, our y, the coefficient of y is 1. So here we are going to maintain the 1. Get it? Then z is also 1. Then let's go to the second equation. So we have our y in the second equation, the coefficient is 0.04. So that one doesn't change. Then the z in the second equation is also 0.07. It also doesn't change. Then for the last equation, we don't have x. So for that one, our x is even 4,000. Then our y is going to be -1, which is the same thing as what we did earlier. Then our z is going to be 1. Now we've got the matrix of x. So you have to find the determinant. You get it? So it's the same process as what we did earlier on. You get it? So now it's going to be 12,000 times this minus this times this, which is what we did earlier on. So anytime they give you get the 3 by 3 matrix, this is how you go about it. So similarly, this is going to be plus, minus, plus. You get it? So plus, minus, plus. So let's do it. So you are getting 12,000, which is this 12,000. Then you open a big bracket into brackets. So this and this, so 12,000, the row and the column on it is, those numbers are not part. So times this, which is 0.04 times 1, 0.04 times 1, then minus into brackets 0.07 times negative 1, 0.07 times negative 1. Do you get it? Then we move on to the second one, which is negative 1. So minus 1. Then we open a big bracket. Then into brackets. So minus 1, then into brackets. So this and this are going to cancel here and here. You get it? So now that is 670 times 1. So 670 times 1. 670 times 1 minus 0.07 times 4,000. So close brackets minus 0.07 times 4,000. Then we go to the last one, which is the positive one. So positive one, this and this are going to cancel. So let's say 670, 0.04, 4,000 and negative 1. So plus 1. Then you open the brackets into brackets. So this and this are cancelling. So we get 670 times negative 1. 670 times negative 1 minus, let me bring the rest here, minus into brackets. So 670 times negative 1 minus 0.04. 0.04 times 4,000. So I hope no one is confused. All right. So we can just punch all this on the calculator. You can do it step by step, but you can just decide to punch all on the calculator. But if you are not sure of how to punch everything on the calculator, you can just do it step by step. But you should be getting negative 1. Then you open the bracket, which is the big bracket, then into brackets 670 times 1, then close brackets, minus into brackets 0.07 times 4,000, then close brackets, plus 1, then you open a bracket, which is the big bracket, then into brackets 670 times negative 1, then close the brackets, minus into bracket 0.04 times 4,000. You get it? So let's punch everything on the calculator. So negative 1 into brackets 670 times 1 minus into brackets 0.07 times 4,000 plus 1, then into bracket 670 times negative 1. So 670 times negative 1, then close brackets, minus into brackets 0.04 times 4,000. All right, so when you do all this on the calculator, you're supposed to be getting 100. So all this is equal to 100. Do you get it? So when you punch all this on the calculator. So if you do it and you're not getting 100, then I advise you to do it step by step. You do this bracket first, you put it down. You do this bracket, you put it down. Do this bracket, you put it down. You do this bracket, you put it down. Then when you're done, you add and subtract all of them. When you do it like this on the calculator, you can easily get it wrong. And for the sake of time, I'm just punching everything at once on the calculator. You get it? So when you punch everything, you should be getting 100. So it means our determinant for the matrix X, which is our MX, is 100. Get it? So let me clean the solution since you've already got the answer. So our MX, is 100. But they said to find the X, you get it? To find the X, we are going to divide the 100, which is our matrix X, over the determinant of M. And our determinant of M is what you solved for in C. So 0.05. So X is equal to determinant of matrix X, which is 100, over the determinant of M, which is the answer we got in C, over 0.05. So when you punch this on the calculator, we are getting 100 over 0.05. So we are getting 2,000. 2,000. And we represented our X by a money market fund, right? So you invested 2,000 in the money market fund. That's what it means. Do you get it? So our X is 2,000. So that's for the D, which is the X. So now we move on to the Y. Our Y was the municipal bonds. You get it? So for the Y2, you're going to be the determinant of the matrix Y over the determinant of M. We already know our determinant of M. You get it? So now let's move on to the all right. So now let's move on to our Y. So for our Y, we first need to find the determinant of the matrix Y. You get it? And just like I was saying earlier, when you are finding the determinant of the matrix Y, whatever you are finding for, if it's Y, you replace the Y values by what is after the equal to sign. You get it? So we are going to replace the Y value. So let's start with that one before we begin. So the Y value, so we have 12,000, then 670. Then lastly, we have 4,000. So let me let it come here a little. So I get in is equal to. So our Y values, what is after the equal to sign? So we have 12,000. So 12,670. Then lastly, 4,000. You get it? So these are the values after the equal to sign. So since you are finding the determinant of the matrix Y, anytime you are finding the determinant for that particular value, the value you are finding for, which is the Y, you replace all those values by what is after the equal to sign. So 12,670 and 4,000. Remember our middle part was the Y, you remember. So now the X and the Y values, they are not going to change. It's the same thing here. So our coefficient for X here is 1, which is what we did earlier on. The coefficient for X here in the equation 2 is 0.03. Then for the equation 3, we didn't have any X value. So here is going to be 0. You get it? Then let's move on to the last one, which is Z. So for our Z, our coefficient for Z in the equation 1 is 1. Because we have Z, you get it, so 1. Then for equation 2, we have 0.07Z. So our coefficient for Z is 0.07. Then lastly, our coefficient for Z in equation 3 will be 1. Get it? Because we have Z. Yes. So now that we've got the values, we can find the determinant. So we use the same approach. So don't forget plus, minus, plus. Get it? So don't forget that. So now it's going to be, so our determinant of My is going to be 1. Then you open the big brackets. So this 1 is going to, so here you are going to cancel this part and this part. So this part and this part is going to cancel. There's going to be 670 times 1. So 670 times 1 minus into brackets. So 670 times 1 minus into brackets 0.07 times 0.07 times 4,000. Then minus 12,000. So here is minus, you get it, because plus, negative, positive. So here is 12,000. So minus 12,000 into brackets. So let me bring them into brackets here. Minus 12,000 into brackets. So for the 12,000, so you cover this side and this side. You get it. So it's, let's say 0.03, then 1, then 0.07 and 0. So 0.03 times 1. So minus 12,000. So let's open this part. So 0.03 times 1. Then close the brackets. Minus into brackets 0.07. So when we close, you are getting 0.07 and 0. So minus 0.07 times 0. Do you get it? All right. So now we are left with the last one, which is 1. So plus 1. And you open the brackets into brackets. So plus 1. So you cover this and this. You are left with 0.03670 and 0 and 4,000. 0.03670, 0 and 4,000. So plus 1 into brackets 0.03 times 4,000. 0.03 times 4,000 minus into brackets 0.02 times 4,000 minus 670 times 0. 670 times 0. Then you close the brackets. Get it? So you can also punch all this on the calculator. 1, then you open a big bracket, then into bracket 670 times 1, close bracket, minus into bracket 0.07 times 4,000, close the bracket again, then minus 12,000, then you open the big bracket, then into bracket 0.03 times 1, then close the bracket, then minus into bracket 0.07 times 0, then close the bracket, then close the big bracket as well, then plus 1, then open the big brackets, then into bracket 0.03 times 4,000 minus into bracket 670 times 0. So let's punch this on the calculator and see what you are getting. All right, so when we punch all this on the calculator, you should be getting 150. So when you do step by step, you should be getting 150. So it means our determinant for my is going to be 150, you get it? So if you punch and you're not getting it, once again, do it step by step. It's because of time, that's why I punched it at once. But when you do it step by step, you're not likely to get a wrong answer. So you punch this, everything in brackets first. Then you do it step by step before you get your answer. So you add and subtract and get your answer. But after you do it, you're supposed to be getting 150 when you do it on the calculator, you get it? So our determinant for my is 150. Do you get it? But you want to find y, and the formula for the y is the determinant of my over m, or the determinant of m. You get it? So now our my is now 150. Our determinant of my is 150 over the determinant of m, which is our 0.05. So it's going to be 150. So our y is going to be determinant of my, which is 150, over the determinant of m, which is our 0.05. So let's do 150 over 0.05 on the calculator. So 150 over 0.05. So you are getting 3,000. So this is equal to 3,000. So our y is 3,000. So it means that he invested 3,000 in the municipal bonds. Because earlier on we said you are going to represent the municipal bonds by y. You get it? So our y is 3,000. Now we are left with z, which is the last one. You get it? And we represented the mutual funds by z. So the mutual funds, how much he invested in the mutual funds. So we go through the same process. I'm sure by now you guys should be able to do it. But let's just do it together so that we'll be able to master it very well. So okay, let me clean this part. All right, so we go to the z. So our z is the determinant of mz over m. So z is the determinant of mz over the determinant of m. So we just find our mz first. You get it? So the mz is equal to... So now we are going to represent all the z values by what is after the equal to sign. You get it? So whatever you are finding for, the values they're just represented by what's after the equal to sign. You get it? So our z values to be somewhere here. So we have 12,000, 670, and 4,000. So 12,000, 670, 12,000, 670, and 4,000. Then our x and y values are not going to change. So our coefficient for x in equation 1 was 1. You get it? Then our coefficient for y in equation 1 was also 1. You get it? Then let's go to equation 2. Our coefficient for x was 0.03. Our coefficient for y is 0.04. Then finally for equation 3, our coefficient for x is 0 because you don't have any x value. And our coefficient for y is -1. Get it? So now that we found the mz, to find the determinant of mz, the same process. So here is positive, negative, positive. Get it? So let's start. So it's equal to, so our determinant of mz is equal to, so 1, because it's positive. So you open the big bracket. So you cover this and this, you get it. So it's left with 0.04, 670, -1 and 4,000. So this part. So it's going to be 0.04 times 4,000. 0.04 times 4,000, close bracket, minus into bracket 670 times -1. 670 times -1. Get it? Now we move on to the second part. So -1. So -1 and open bracket, a big bracket. So this part, you cover this and this, you get it. So it's left to 0.03, 670, 0 and 4,000. So 0.03 times 4,000. 0.03 times 4,000. Then minus into brackets 0.03 times 4,000 minus 670 times 0. So minus 670 times 0. This is 670 times 0. Then go to the last one, which is 12,000. That part is positive. So plus 12,000. Then you open a big bracket into brackets. So you close this and this. So you cover this and this. So it's going to be 0.03, 0.04, then 0 and -1. So 0.03 times -1. 0.03 times -1. So 0.03 times -1. So if you are covering this and this, 0.03 times -1, then minus into bracket 0.04 times 0. 0.04 times 0. 0.04 times 0. Alright, so we are going to punch all this on the calculator. So if you punch all this on the calculator and you do it properly, you should be getting 350. So one thing I also advise you to do is that anytime you are writing, you are solving a question on matrices, especially in exam, please take your time when it gets to this particular part, you get it. If you don't take your time, you'd get this part wrong. And once you get this part wrong, the whole thing is going to be wrong. You get it. So please, this part, please take your time. Do it step by step. You get it. So when you do it step by step and you punch the values accurately, you should be getting 350. So our determinant for MZ is 350. You get it. We are finding for Z. So our Z is our MZ, which our MZ is 350. So our 350 over our determinant of M, which is 0.05. 0.05. So what is 350 over 0.05? 350 over 0.05 should be getting 7,000. So our Z is 7,000, you get it. So it means he invested 7,000 into Z, you get it. So now the first one for X, we got 2,000. For Y, we got 3,000. And this one, you're getting 7,000, which is our Z, you get it. So when you add all, you should be getting 12,000. So 2,000 plus 3,000 plus 7,000, you're getting 12,000, which is how much he invested into it, you get it. So it means our answer is correct. So another thing which is good about this question is that after you are done, you can be able to check if your answer is correct or wrong. So when you add all the values for X, Y, and Z, remember in our equation 1 was X plus Y plus Z is equal to 12,000, you get it. So even when you try for the second and the third equation, it should be equal to this one. You get it. So the value for X, the value for Y, and the value for Z, when you add it should be equal to 12,000, you get it. So yes, so that's the last thing in the question, right? Calculate the amount John invested in each type of fund by using matrix algebra. All right, so we are done for this particular question. And if this question is going to come, I don't know how many marks you're going to get for this question, but it's going to carry a lot of marks. So please try and go over it to get it. If there are other examples, probably if there are trial questions, we'll solve them as part of this one. But most of the time, the questions are like this. So if you don't understand, you can watch the video again and take your time and also try and solve it whilst I'm also solving it so you get an idea of how to do it, you get it. All right, thank you very much for watching today's video, and I'll see you in the next video.